Hi to everyone. I'm Gary Lane, a director of Sim1 at the Mandela Mining Precinct. I wrote this paper in 2014 for the 6th International Platinum Conference for the Southern African Institute of Mining and Metallurgy. It was a case study on using a value driver tree as a means of integrating disciplines and activities. I've been wanting to record a example of this actual case study, and now the opportunity is here because technology has got to the point where we have value driver tree software that allows it to be used as a mainstream business tool. So I'll take you through this case study. This case study is of a mining operation. I have changed all the numbers in this case study so that it's not the real numbers, but the whole concept of the case study is shown. So here we actually modeled the full value stream. So we modeled from drilling right through to recovery and sorting. So it covered drilling, blasting, loading, hauling, crushing, all the activities. Each of these KPI sheets show the actual performance of each of these different areas. So we've done 4.2 million meters of drilling in the year, 11.2 million tons blasted, 9.2 million tons loaded. We've got an actual, a scenario one, and a target. So the actual is what was achieved for the year. Scenario one at the moment is exactly as per the actual. So we'll run a scenario, and then there was a target, which is really what the best demonstrated performance is and what their plan is for the year. So what I'm going to show you now is we're going to go through and have a look, first of all, at the overall operation. So this is the EBIT for the year. They were showing in this hypothetical example 634 million as the EBIT. Target was 1.1 billion. So we can drill down in this value driver tree so we can see revenue is then made up of carats recovered, China exchange rate times selling price, and your carats recovered is your head grade times mindful factor times ore tons, which are the tons that have been processed. And then the costs are also broke down into all their details as well. Now, one of the first things that are very useful in a workshop is to, or even in your operation, if you're using this for performance management, say, okay, well, we achieved 634, we wanted to achieve 1.1. What's the biggest reason for variance? Now, it's a thing called an impact analysis or attribution analysis, and we can compare what was our target to our original actual. And what we can see here is that, in fact, we should have got 1.13 billion. We actually got 634 million. We were better. We got extra 170 million of EBIT from selling price being a bit higher. But our ore and we did less ore tons, which actually had less variable costs, so that shows better. But we had a massive reduction in the actual revenue because of the ore tons that we didn't mine. That should have we lost almost 560 million of EBIT because of ore tons. So you can see a little bit of other areas here, fixed costs a bit higher in that as well. So now we want to find out where to focus. So we know it's our ore tons that are an issue. All right, so let's go and have a look here. So what we looked at originally was our value stream. So you can see now we've got all our drilling, loading, hauling, crushing, all of them. So the big question is, where do we focus? Now, there's a very, very important concept, which I'm not going to go into detail in this case study, but it's a thing called a common metric. The only way for you to evaluate a value stream effectively is if you convert all of the metrics in the value stream to a common metric. So we converted all of these to a common metric, which is ore tons. And if you have a look at the common metric here, you can see straight away that hauling is actually the constraining activity. Everything else didn't constrain this activity for this value stream for the year. So if I look now at hauling, and let's drill down into hauling. So we did 9.2 million tons. You can see here we could have done 15.4 million for the year. So 66% better than what we actually did there compared to the target. So let's drill down into hauling. Now, we built a value driver tree for every activity, but hauling is the one that had the biggest is the constraining activity in this value stream. So any activity can really be modeled as the direct operating hours, how many hours that machine or that activity ran for times its throughput rate. So if we drill down into our direct operating hours, we can see it's available hours operational delays. Now, it's very important to get your time model right for an operation. I mean, you really need a standard time model. Available hours is calendar time minus planned maintenance done unplanned maintenance. So there you can see the actual calendar time, that's 365 days for the year. Planned maintenance, 3,100 hours. Unplanned, 1,900 hours. Let's look at operational delays. And it's made up of external delays, which is something external of the system, such as fall of ground, rain delay, maybe labor unrest. Internal delays are anything internal to the activity. So if no operator was available, that would be a internal delay as an example. Breakdowns are sitting in engineering in downtime, so it wouldn't be part of internal delays. Choking and starving, very interesting ones. Those are very often not well captured. But all you really need, that's consequential downtime. Starving means hauling was not getting material from loading. Choking means that it could not tip into the crusher. So you can see 4,000 hours of choking in the year, 5,500 hours of starving. Internal delays, 10,500 hours. Very, very interesting. So we can break it down, look into more detail. So again, a very useful tool is to use what's called an attribution analysis or impact analysis. So we look at what was our target, what was our actual, and look at this. Our loading time, we actually did better. So our loading time was less. So we actually got 1.62 million tons more because of better loading times. Choking was less. Planned maintenance. So interestingly, we did less planned maintenance, which is probably a bad thing. And then we lost a lot of tons. Here's all the reasons. Now, you don't want to be focusing on all these things. You want to really focus on the big stuff. So look at this, 5.3 million tons for one reason only, no operator. Now, that's crazy. You've got a 20 million rand piece of equipment. It's been maintained, it's available, and you don't have an operator to operate it. So let's have a look at the value driver tree, and let's go down to no operator. Now, look at that, 9,500, and the hours is correct. This was actually what was on this operation, 9,500 hours of no operator, all right? And we can run a scenario now. So let's actually make that 0, and let's see what happens if we make it 0. So I'm going to change it to 0, and I'm going to rerun that scenario, and we're going to see what. So straight away, the scenario goes up to 14 million tons mined, which is incredible. Just one metric. And if we go and have a look now at the EBIT, we'll see straight away what impact it had on the EBIT of this operation. So you'll see that straight away we can get to almost 1.1 billion just by fixing that one thing. Now, when we spoke to what we did here is we sat with HR with this value driver tree, we sat with finance, we sat with mining, we sat with engineering, we sat with all the different disciplines, had a discussion around what variables can they control, because these are really leading indicators that you can control to improve the performance of this operation. And the head of HR sat back on his chair, and he like laughed and all smiled and said, I asked for more operators, and the GM said to me, you know what operators cost? And all he needed, now if you work it out, 9,500 worked out at about 118 operator. It was 4 operators a month extra that was required. So it's not significant compared to the almost 500 million of value that was available in this operation just for that one metric. Now, there's a whole lot of other metrics we can focus on, but in this case study, I just wanted to give the example of how just that one metric, how it could have pushed everything up here in terms of achieving 1.1. Now, just another few important things about a value driver tree. You can see names here. You can now have specific people accountable for specific metrics, which are very, very important. And if you look at an operating model for an organization, or what we call our operational systems capability, and you look at levels of work, you want to integrate measures of performance with levels of work. And a value driver tree is a great way to integrate levels of work and KPIs. Thank you very much for listening. I hope this was useful. This is just a portion of the case study, but feel free to contact us if you want any more information. You can also scan my QR code there for my full details, or email me directly. Thank you very much.